Howdy folks, John here. In today's video we're going to be talking about flight stabilization mode selection in collective pitch RC helicopters. Stabilization questions, some of the most common I get asked. There's 8 reoccurring ones primarily. So I just thought I'd do a video to address these, demo some of it, hopefully to help you guys out. The video will be divided into time chapters, of course, and each question will have its own chapter. Let's get to the first question. Questione number 1. How does self-level differ from normal gyro mode? Well, really to answer that, we have to go outside for a flight, which we will do at the end of the video. But real quickly, just a couple of little points to mention. This is pretty basic stuff. Self-level mode, as the name would suggest, if you're flying along and you center your cyclic stick, the helicopter will immediately come back to level. It's very robotic and very abrupt. Whereas in normal gyro mode, if you do that, you're flying along and you center your cyclic stick, it's not going to level out. It's just going to keep flying forward and will slowly over time level out until you actually give it a counter command to correct for that and get it back into a level flight. Now I should mention, even in self-level mode, depending on how much mass your helicopter has, when it self-levels, because there is momentum there, it's going to keep moving, but you're not going to have to give as much corrective command to stop it. But it's not going to stop on a dime like a GPS system would do. And the other thing in self-level mode that's different from normal gyro mode is it will not allow the helicopter to pitch or roll past a certain attitude, meaning pitch angle or roll angle. Most of them are anywhere between 25 and 35 degrees. So you could give it a full cyclic command forward and it will pitch to maybe 30 degrees or so, and it won't go any further than that. Whereas in normal gyro mode, if you give it a full forward stick command, especially if you've got lots of cyclic pitch, it's just going to keep going over and over and over until it's upside down. So those are the main differences, but we'll see them when we go for the flight test at the end of the video. Questione number 2. Is self-level the same thing as 6G or 6 gyro? Yes. This is where marketing terms are all over the place. There's 6G, 6 gyro, safe, that's blades, what's that stand for? Sensor assist flight envelope. There's attitude or Atti mode, horizon mode. I just call it self-level because that's what most accurately describes it. Have no idea where the 6 gyro came from. That's just nonsensical. The IMUs don't have 6 gyros in them. They have 3 gyros on the pitch and roll axis, of course, and 3 accelerometers on the pitch and roll axis. If they want to use the word 6, it should be called 6 sensor, not 6 gyro. But whatever you want to call it, it does the same thing. It auto levels the helicopter and keep it from flying past a specific attitude of pitch or roll angle. Question number 3. Is 3D mode the same thing as normal gyro mode? Yes, it is, but I hate this term because it really confuses a lot of people. You know, they think, well, 3D, I don't fly 3D, so I can't be in that normal gyro mode. I have to be in auto level mode, and that is so far from the truth. It doesn't matter what type of flying style you do. Just because you're in normal gyro mode doesn't mean you have to fly in 3D. Of course, to fly in 3D, you have to be in normal gyro mode because in auto level mode, as we know, it won't allow the helicopter to pitch or roll into inverted orientation, which is generally implied with 3D flight. So if you want to fly aerobatic or sport, definitely you have to be in normal gyro mode or just normal scale flying. Normal gyro mode is going to give you the most realistic looking scale helicopter. Question number 4 now. Is self-level mode or gyro mode the same thing as flight mode? Nope. In the world of collective pitch RC helicopters, flight mode is generally referencing what pitch and throttle curve selection you're using while you're flying. And you can change between those pitch and throttle curves on the fly, and that's your flight modes. For instance, a tame normal flying style flight mode, you might be running a rather low head speed and maybe a collective range of -3 to +10. And then when you switch into your idle up or your stunt 1, stunt 2, whatever, you're going to be running, a more symmetrical collective range, so you can do aerobatics, maybe -10 to +10 at a higher head speed. Now that doesn't mean that you can't assign your stabilization mode selection channel, generally channel 5 on these little guys, to your flight mode toggle. So in a programmable radio, you could do that. So in your normal flight mode, you could have self-level turned on if you wanted, and then in your stunt 1 or stunt 2, have it turned off into normal gyro mode. Which brings us to question number 5. Okay, this one should get some negative comments and a few thumbs down. Why do you and other instructors recommend against learning in self-level mode? I'm sure you've heard the saying that a building is only as strong or solid as its foundation. And that analogy holds so true for learning to fly collective pitch helicopters. Your basic tail-in hover. This is what every other skill moving forward is based on. So this is your foundation, mastering the tail-in hover. And why is it difficult? Well, you've probably heard me or others say that hovering a collective pitch RC helicopter is very much like balancing it on a top of a ball. And really, that's what you're doing. You're balancing it on a dome of high air pressure. And it doesn't want to stay there. It always wants to roll off that dome in any direction. And it's your job as the pilot to actively bring it back so it's level and back into a hover. And when you're first learning this, all students, they'll be overcorrecting, it'll be going all over the place. But the whole time you're doing it, every second, you're building subconscious memory and hand-eye coordination. And after a while, something just clicks and you get it. And you're holding a tail-in hover and not even realizing all the command inputs that you're making to keep it there. And it is an immensely rewarding experience. It's one of the things I love about instructing is seeing people when they achieve that moment. There's nothing like it. I'm so happy for them. I get to relive it all over again from when I learned. And like riding a bicycle, once you get it, you'll never forget. And you may be thinking, well, I'll learn first in self-level mode and then I'll just relearn later. Well, back to the building analogy, it's a lot harder to fix the foundation once the building's on top of it. And same thing here. It takes most people a lot longer to relearn than later on. So do yourself a favor, learn the tail-in hover without any self-level help on, get to experience that eureka moment, and you'll have so much fun. Secondary, if you're flying at an RC flying club, there's a good chance that to get your certification so you can fly at the club by yourself, that you have to prove that you can hold a tail-in hover without any self-level help. Here in Canada, we're on Max Blade program. And to get your basic heli pilot proficiency certification, you just have to show the instructor that you can hold a tail-in hover under your full control. You don't have to be side-on orientation or anything, just a nice, easy tail-in orientation. But that is the foundation. And once we see you being able to do that, you're good to go. You can fly at the club by yourself anytime you want to then. And, don't think you're going to crash more, because really you shouldn't. A collective pitch RC helicopter in normal gyro mode with a tame learning to fly setup will be just as docile and easy to fly as in self-level mode. Some people even think it's easier. For example, a nice tame setup like we've got here with normal gyro stabilization. This has no self-level help turned on. Really tame setup. I'll show you full cyclic throw. That's full forward backwards. That's how tame it is. Right, left. As easy or easier to fly than in self-level mode. And most importantly, you're learning the real feel and balancing act of hovering a collective pitch RC helicopter. And with the tame setup like this, if you get into trouble, it's pretty much impossible to do any damage to the helicopter as long as you're staying within a foot or two of the ground. And with this tame setup, if you give a full low panic attack stick command, comes down nice and soft, doesn't auger itself into the ground. And as you can see, we've got training gear on. That's to help not only prevent the helicopter from tip over when you're doing your low ground hover exercises, it's also to give a visual reference of how the helicopter is pitching and rolling, so you can react much quicker. And as long as you're in ground effect, you don't even really have to play with your collective that much, because your lift is self-correcting. As you get closer to the ground, the air pressure builds. I'm just flying with cyclic right now. I'm not even using my collective. Question number 6. How do I know if self-level help is turned on or off? Now this is going to be RC helicopter or flybarless system dependent, but most flybarless systems or flight controllers will have a little visual light to show what stabilization mode you're in. OMP here, as you can see, when it's in normal gyro stabilization, the little red LED inside there is flashing red.
Self-level mode.
When it's in self-level mode, the red LED will be solid. And this is pretty typical of quite a few of them. Now, if your flybarless system doesn't have a visual indicator to show what stabilization mode it's in, you can also watch the swash plate behavior to figure it out. So in auto level mode, I'm just going to pan the camera up so we can see the swash plate directly side on. So when I tilt the heli forward, the swash plate is going to tilt backwards because it's trying to level the helicopter back out, of course. In self-level mode, it will lock. It won't slowly move back to level. Same thing with roll. Tilting it left here, the swash is holding in right cyclic. Tilt it right, swash is now holding in left.
Acro mode.
In normal gyro mode, if you do the same thing will happen, but the swash plate will slowly level back out. It doesn't stay locked. It will move back to level, just like a flybar would level back out in flight. So that's an easy way to tell from swash plate behavior what stabilization mode you're in. If it levels back out after you tilt the heli, or mostly levels out, you're in normal gyro mode.
Self-level mode.
If it stays locked, you're in self-level mode. Question number 7. How do I set up my radio with a self-level enabled RC helicopter or flybarless system, and what gain setting do I use with self-level? Best advice I can give you here is to check your owner's manual, because they're all going to be different. Now, on the OMP with their internal protocol, their receiver inside is mapping out stabilization mode selection to channel 7 output. On most micros, however, it's going to be on channel 5 output. So that's where you would want to find out what channel selects your mode selection, and then you would hook a toggle up to that. So hopefully you can see the little red light is blinking, indicating we're in normal gyro stabilization mode. That's with channel 7 output at 2012. And if we hit the toggle for channel 7,
Self-level mode.
we can see the red LED is now solid. So that could also be for channel 5, however. Okay, that's with most micro helicopters. With larger helicopters, with higher end flybarless systems, again, most are channel 5, and then you set your tail gain on channel 7 or maybe 8, which is a totally different thing. And that's, I think, what's confusing a lot of people as well, is setting gain up. Stabilization selection doesn't have a gain setting. I could set channel 7 output here to, somewhere midpoint, like 50%, 50%, and it would still turn stabilization on or off, but it wouldn't affect the behavior at all. So there's really no gain associated with stabilization mode, at least with most. That's a generalization, but you're pretty safe with that bet that no matter what that output is on your stabilization mode selection channel, it's not going to change the amount of gain or anything for the helicopter. Most of these small micros, they don't have remote gain. You set the tail gain up in the unit itself, which brings us to our last question. Is self-level mode the same thing as rescue mode? Okay, the best way I can answer that is sort of. Rescue mode certainly does use self-level. Okay, when you engage rescue mode on a flybarless system, it's using the self-level function to level a helicopter back out. But it generally introduces 2 more functions to self-level. It will usually also add a bit of collective pitch pump. So the idea there is when something's going wrong, you're probably losing altitude, and shit's about to hit the fan. So it will add a little bit of collective to stop the descent, or at least slow it, while it also levels out the helicopter. This can be both upright and inverted. And in higher end flybarless systems, they actually allow you to program that for the amount of collective pitch pump it gives and for the duration. The OMP here, its self-level mode also does function as a rescue mode. And the way you can generally tell that is to flip the helicopter upside down. Let me just go into normal gyro mode again. So here when it's upside down, we can see the swash plate behaving like it did when it was right side up in normal gyro mode. We tilt the helicopter, the swash tilts, but then it slowly levels back out. But as soon as I hit self-level, the swash plate will tilt, will roll one side or the other. It will never level out because it's always trying to roll the helicopter back into an upright orientation. So that would be one way to tell if you've got rescue mode. When you engage it, you'll see the swash try to roll the helicopter over. But again, no collective pitch pump with this one. And some higher end flybarless systems, you can program in if you want the helicopter to flip right side up when you hit rescue, or if you just want it to self-level while it's inverted and maybe gain some altitude. So I guess the short answer is self-level mode the same thing as rescue mode? Yes, rescue mode just takes it another step further. Let's get outside and actually see the difference between self-level and normal gyro mode. So we're in self-level mode right now. I'm just going to give some cyclic commands. I'm going to give a full forward stick cyclic command. And as soon as I center the stick, as you can see, the helicopter levels out. Thus self-level or attitude mode. It keeps drifting for a while from momentum. The bigger the helicopter, the more pronounced and longer that drift will last, generally, depending on how the flybarless system is set up. But it's very hard to fly fluid flight with self-level. It's very robotic. And of course, it only allows you to pitch to a certain angle. If I hold in full forward cyclic, that's the maximum angle. What is that, about 30 degrees here? That's full forward. Same with left and right, full left. It doesn't allow you to pitch or roll past that angle. So that is why you can't fly acro or 3D in self-level mode. And again, don't confuse stabilization mode with flight mode. If I go into my idle up flight mode here,
Idle up 1.
so I've just increased the head speed and the collective range, but I've still got self-level turned on. So again, flight mode and stabilization mode, two totally different things. So if we turn auto level off now,
Acro mode.
so we're just in normal gyro mode now. The difference is if I push forward cyclic and center the stick, it still keeps moving forward. Try that again, get a little bit closer here. So give it a little bit of forward, it just keeps moving forward at that same angle, more or less. So my sticks are centered, but as you saw, it's still coming towards us. And it's still pitched forward slightly. And also, unlike self-level mode, if I continue to hold full forward stick in, it will just keep pitching forward until it's upside down. So big difference between the two stabilization modes. And in normal gyro mode, that's what allows you to really get a feel for the helicopter. This is what helicopters are supposed to behave like. Very fluid. There should be no robotic feel to them. They're kind of sliding around in the air. You know, and that's what you're after when you're flying a collective pitch helicopter. You don't want it to behave like a quad rotor. That's part of the hobby. And whether you get into 3D or even scale flying, you're never going to mimic what a full-size scale helicopter flies like in self-level mode. But you're certainly going to mimic what it flies like in normal gyro stabilization, because this is the way full-size helicopters behave. You know, there's lots of momentum behind them, and they skate around in the air. And nothing flies like a collective pitch helicopter when you don't have self-level turned on. That's the uniqueness of flying a helicopter. Even if you don't do acro.
30. 20.
Immensely enjoyable flying experience. I should mention tail response, no difference with self-level help turned on or off.
6, 5, 4.
Self-level, though, generally on most flight control or flybarless systems, it dumbs down the response of cyclic and tail. That might be the only difference you experience. Thanks for watching, folks. Happy flights.